the main purpose of this aspect of statistics is more of a means to an end. So it's always advisable that even though we're going to have an overview of some of these topics in theoretical aspect, it's best to have to take time by yourself to do practical sessions in order for it to get engraved in your mind. Because in retrospect, most of these topics are a bit technical, or more like it's a means and you need to understand where and when to use it or identify them. And this you can do when you have like time to go through scenarios over and over and over again. That's basically it. So diving into the first aspect, we've done a review of data types, and the topic right now is percentile. And percentile basically is the percentage of the data or data points that is below the amount in question or at or below the amount in question. So what does all this mean? So if you look at this particular graph, we have an x-axis that has particular list of numbers. And if you notice, these numbers are discrete. They're not numerical, they're actually discrete. Another thing to take note of is ordinal data. So categorical ordinal data can also be switched to discrete. So what does this mean? It means that gold, silver, bronze can be switched to 1, 2, 3, and that's already discrete. So let's assume this particular number has to do with the daily driving times or hours for drivers, and these points are like drivers, basically. So if we want to ask, if somebody wants to ask a question like, what is the percentage of drivers that drive at or below 6 hours? So basically the idea is to first count all the data points on the left side of 6. So if we want to count, they're about 8. So 3, 3, 2, 8. And the total data point here is about 14. So it's 8 divided by 14. That should be, just give me a moment. 8 divided by 14, that's 5.7, 0.5.7, and times 100 is 57, approximately 57%. So we can easily say from here, like 57% of drivers drive on a daily basis between 6 hours. And let's try to do this in Python. So first of all, does anybody have any question based on what the percentile is? Okay, I guess not. So first of all, we impute our libraries as usual. And let's say we have this data point. Let's say we have this data point running between 10 and 1.9. And who can tell me what kind of data points are this? What kind of data type is this, rather?
Numerical.
Okay.
Continuous.
Thank you. Continuous numerical data or continuous data. That's also a numerical data. Thank you so much. And say, so there are two ways of writing the percentile. So let's say the question is, what is the 50th percentile? If we're going to do this manually, which is not advisable if you have so much data, but let's say we're going to do this manually, we remember from the last class that the 50th percentile is basically the middle. So manually, or in numerical, in layman's terms, first of all, we arrange from lowest to highest. So that'll be 2.0. No, okay. Not sure. Okay. Okay. That'll be 2.0 and 2.3 and 3.0 to 3.4, 4.6, and what else again? So 1.1, 4.6, 7.6, and 10.5. So manually, basically, if we want to get the mean of this, we look for the middle one, and basically the middle one out of this 11 data points is 3. And 25% of this basically means the middle of the middle. And if 3 is the median, it means the middle from here, from the median downwards, is 2.0. But let's see how we do it in Python. So basically put it in NumPy array so that we can easily manipulate it. And we use the percentile in the NumPy array library to solve it. Oh, sorry. So first of all, we impute this. First of all, we impute this and we ask, what is the 50th percentile of this particular data point, which is 3, and the 25th percentile is 2. If we're going to say, okay, what is this 75th percentile? If we're going to do it manually, given the data is quite small, in order to understand what is happening in Python, we say, okay, so the middle is 3. So 3 upward is probably going to be 75% is greater than 50, and the middle is 3, and probably the 75th percentile is 4.6. And that's basically what we get if we do the same thing in Python. Great. So the next topic is probability and probability distribution. Basically, it's actually probability distribution, but before you get to probability distribution, you have to understand what probability is in the first place. The word probability is the likelihood of something to happen. So it's like when you're having a conversation with someone and he is like, how likely is rain going to fall today? And somebody say, there's a 50% chance it's going to fall today. The person is already dealing with probability. And these are things we do every day as we talk to people or as we analyze things, even in rudimental terms. It's also good to know that probability is basically between 1 and 0. It's not 2, it's not -1, it's between 1 and 0. Can anybody tell me so we did a bit of frequency and frequency last time when we're talking about mode. Does anyone know the difference between probability and frequency? Do you think it's interchangeably, or do you think it's different basically? Edwin, you want to try?
I think is okay. We're asking of the mode, right? Mode and probability.
No, so basically frequency and probability. Do you know if there's a difference? And if there is, what's the difference?
For me, I think frequency is the occurrence of the data set. That is the occurrence of events. The number of times an event occur. Then probability is both the outcome, both the number and the overall data set points. I don't know.
Yeah, I think you're on the right track. So let me try to refine what you just said. So basically frequency, it basically measures how often an event occurs. And a typical scenario is if you're in a room and, or basically in a room where there are 3 males, 5 females, and there are 2 children, the frequency is basically the 3 to 5. So you're basically saying there are basically 5 women in the room in terms of occurrence, like how often they occur, 5. How often do males occur in this particular room? 3 times. How often do children actually occur? 2 times. That's basically frequency. And if we're going to combine our knowledge of